Alright, so today we're looking at transformations. The graphs, we looked at a couple of transformations the other day. We looked at the dilations this way and this way, so from the y-axis and from the x-axis. But we can also translate. So here's our dilation from the x-axis, dilation from the y-axis, to change these numbers. But we could also put a number in there with the x or a number on the end. And you probably already, hopefully, have an idea that when you change those numbers, then they'll move. So this is in decimal, so 1.57, so it's about the pi on 2. And you can see now that this part of the graph has now moved over to there, so it's indicated. So we've shifted that. Also, you could move up and down, so that would be the number on the end here. Alright, so that number on the end is now 3. So our starting point, instead of being 0, 0, is now pi on 2 to the right and 3 up. So we're now starting there. In terms of the amplitude and the period, because I haven't changed these numbers, no change. Alright, so, and if I look at, that's the sine one, cos one. Alright, so here's the cos one. They're the same thing. So here they've called them C and D, we call them H and K. And you don't worry to get distracted by that plus, just whoever wrote this particular thing has decided to put a plus there. So if I change that number there, the C, as we know from the others, turning left and right. And then the D on the end, up and down. And again, the amplitude and the period, no change with them. All right. So transformations, so today we're looking at y equals a sine or cos and x minus h plus k. And from what we did the other day, the A is a dilation from the x-axis, and we would call that the amplitude. The N we did the other day, that was a dilation from the y-axis. And when we made that number bigger, so that would be this one, when we made this number bigger, what happens to the graph? It gets smaller, yeah, the period changes. Alright, so dilation from the x-axis, so to indicate that it gets smaller, factor is 1 on n, and as Glenn said, the period changes as well. So, and that's 2 pi on it. All right, so that's what we did the other day. The h is a translation, left or right. And the k is translation up or down. All right, starting points. All right, they change. Now, if what I'm about to write, if you like this, good. If you don't, there's other ways of doing it, so don't be too stressed. All right, so the sine one. So the sine one is pretty simple. So it's usually 0, 0. And because in this case I've moved to the right, pi on 2 and then up 3, my starting point is now there, pi on 2 and 3. So which is simply the h and the k. The cos one's a little bit more involved because...
Would there just be h and then 1 plus 2?
You're on the right track there, yeah.
Yeah.
So because it starts at 1, but because we've got an amplitude, if the amplitude's 1, it's 1, but if the amplitude's something else, it's whatever that is. So yes, you're on the right track there. So if I change my amplitude, so the A, so I make that 2 now. All right, so yes, it's been moved across to here, to pi on 2, but because my amplitude's 2, it starts there, and then of course if you move it up, so it's been moved across, it's been moved up, and then we've got our amplitude on top of that. So it's h, and k plus a, the amplitude. All right, so when we're sketching, if we can figure out where it's going to start, then we can put our period and that in and then use the patterns. So let's do a couple of examples. All right to rub that off.
Yeah.
All right, this is the first example. All right. Now, something else I need to point out to you, that when it's in this situation here, yes, the n is 2. However, so that you get the translation correct, it needs to be written in this form here, where you have the n out the front of a bracket. So sometimes it will already be written like that, other times it's there in the bracket. So what we have to do first of all is we have to take that 2 out. So So we need to take that 2 out as a common factor. So if we're taking 2 out as a common factor, this pi on 2 will become pi on 4. Alright, so if you forget to do that, you'll still get your period right, but what you won't get correct is the translation. Alright, so the pattern for the transformations works when you have that out as a factor. Okay? If you don't have that out as a factor, the pattern for the translation doesn't work. And remember, we're using patterns here. Alright, so our period then would be 2 pi over 2, which is pi. Alright, translation. We've got 1. What is it?
The 1 that I 4.
And it's to the right, isn't it?
Yeah.
Our amplitude,
3 sorry, 1
Yep.
over 2.
is 3. And where are we going to start? Alright, so it's a sine. So a sine would normally start at 0, 0. We've got a translation to the right. So it hasn't been translated up or down, so it starts at 0 there. But the x
Now it starts at pi over 4.
pi over 4, right. Okay, so we can use that to help us sketch. So because we're starting pi on 4, I'm going to mark off in pi on 4s. Alright, now I haven't written in the question how much we want to draw. Sometimes it says 1 cycle, other times it will give you a domain. So I'll just draw 1 cycle. Alright, and so because my amplitude's 3, I've marked a 3 there and down to 3. I haven't translated, there's no translation up or down, so I don't need to worry about that. Okay, so our starting point. So it's going to go up, it's going to go down, it's come back up. So when it comes back up and gets to this point, it would be 1 period later, which is pi. So 1 period after pi on 4. Pi on 4 plus pi is 5 pi on 4. So it goes up, it comes down. Where does it come across the axis on the way down? Halfway between. Yep. So 3 pi on 4 there. Goes up, comes down. So the highest point is in relation to these two where?
In the middle.
In the middle. And its amplitude is
3.
so it's up there. Alright, comes down, and in relation to these 2 points, again in the middle, at -3. So 1 cycle of our graph looks like that. Alright, so using the patterns of the transformations and the patterns of the sine and the cos, once we work out our starting point, we know our period, then we can, so once we've got these 2 points, we can fit all the rest in easy, because this one's halfway between there, that's halfway between there, that's halfway between there. So using that. Alright. Let's do a cos one, shall we? Alright. I'm all right to rub that off. Okay, so with this one, y equals 2 cos 2x minus 1. So because there's no bracket here, that means this on the end is translation up and down. If there's a bracket around it, then it's left and right. Now sometimes you may see with the bracket written around the 2x like that. Alright, so whether that bracket's there or whether it's not, means the same thing. Alright, what's our period? Pi. Yep. Pi. What's our amplitude? Yep. And we've got a translation, which way? Alright, down 1. Alright, so something else I didn't point out, but I will now. So if I go down 1, so if you think about down 1. So if we think about our standard one here, then our x-axis is the midline. So if we're moving down 1, then the midline of this red one here, the midline of that, is also moved down 1. So when I'm looking at going up and coming down, this point here, it's not intersecting the x-axis, but it's intersecting y equals minus 1. So again, this point here, right? So when we're looking at that symmetry, that's what we're going to look at. So from these two things, there's a couple of things that we can get. So first of all, so our midline, let's call it the midline, is now y equals minus 1. But when we put these two things together, they are going to do our starting point. So amplitude is 2. So if this one's an amplitude of 1, the amplitude of 2 would put this point up here. But then we've got a translation down, yes? So it's going to move the point from there back down to 1, okay? So let's go again. This is amplitude of 1, amplitude of 2, translation down 1. So it's going to start at 1, at 0 and 1, I should say. Not 1 and 0. Okay. So let's sketch that. So this time I'm given a domain that I want to sketch sketch it over. So my domain I'm told is 2 pi, so I've got to go to 2 pi. Alright, so in green I'm going to put that midline on there, and that midline, just going to use that to help with our sketch. Alright, so let's go. So we've got a starting point, we know where we're starting. We know where what our period is. So we're starting up here. So with cos, then goes down, comes back up. So it'll get back to its peak whereabouts? Pi. Yeah. So pi, which is there. And then I'll do the first cycle first. So, for cos, the lowest point would be in relation to these two. Halfway between. So, pi on 2. Now, the amplitude is 2, so that's 2 below this midline, yeah? So, I haven't gone far enough. 1, 2 below. So, I need to add an extra 1 down here. 3. Alright, so it's 2 below the midline, so down there. So it's going to cut through the midline on its way from here to here. And in relation to those, it's halfway between. So here. And then on its way up, it's going to cut through that midline, again, halfway between. So here. So one cycle of it looks like that. We're asked to do all the way to 2 pi, so we just need to repeat that pattern. All right. So when you're sketching it, that's all you need. If you are asked to find x-intercepts, you can find them. Now, that solving of equations that we did, you would need to use that technique. No, because because the midline, because it's the translation down.
Yeah, but like, wouldn't it be halfway between, like?
Not necessarily, it depends on the amplitude and the period and the translation as to whether it's halfway between or not. So it's more complicated than that. So that's why I use the midline here, because it's a bit, because you can use those patterns to do it. But if you specifically ask, you have to solve this equaling 0, so it becomes more complicated. All right, but if you're not asked to find specifically to find the x-intercepts, then you don't need to. All right. Any other things people need me to clarify? No. All right, so this is exercises 6F and exercise 6G. So in the textbook they've they've separated them to the two different.